Okay, good afternoon everybody, and welcome to the schools in the room, but also to the schools that are listening in, the young people that are listening in online, hopefully from around the UK and maybe from around the world, we don't know yet. We're live streaming here from the Space4Climate stand. I'm Beth Greenaway and I'm from the UK Space Agency. More importantly, we're here at COP26. Hopefully everybody has heard of COP26, and we're here in the green zone. Just behind us, across the River Clyde, there's 120 countries and many other organisations campaigning and discussing climate change and what we can actually do about it to make a difference. So, as I said, I'm from the UK Space Agency, but I'm here representing the Space4Climate network, and it's such an honour to be here today with Tim Peake, an Easter astronaut. I've also got with me the experts who are part of this network. So we've got Donna Lindsay from the Ordnance Survey, Fred Worrell from the University of Durham, we've got Sam Fleming, co-founder and head of operations at a company called Earthblocks, and Heiko, Director of the Centre for Landscape Climate Research, University of Leicester. Okay, so hopefully we're going to attempt to answer some of the brilliant questions that have been left. During this week, the first week of COP, people have been walking past and writing questions on the board. I don't know if you can see the board there. They are all genuine questions that have come in. We've also been asking schools across the UK to ask us questions online, and we've picked some of them to see if we can answer. The ones that we don't answer now, we're hoping to write up the answers to, and you'll find on our website later on. So if I can turn to Tim first. You've spent over 6 months in space. Whilst you were in space, did you see any signs of climate change on Earth?
Well, yes, you do, Beth. When you look down on the planet, you see signs of both the cause and the effect of climate change. And in terms of the cause, for example, when you go over South America and you see the Amazon rainforest, you can see vast areas of deforestation, and we know that that's contributing to climate change effects. Or if you go over the Himalayas, which are stunning and beautiful, but then you look down to the south and you see the levels of smog that are being built up on the southern parts of the Himalayas, and again all of that pollution is contributing to the climate change effects. So two big causes we see straight away from space. And then you see the effects. In 2016, when I was on board the space station, we had very large wildfires in Alberta, Fort McMurray, and the smoke from those fires covered the entire continent of North America. And as an astronaut, you know why, because when you see Earth's atmosphere from space, it is tiny. It's 16 kilometers thick. If Earth was a football, our atmosphere would be a sheet of A4 paper. And that smoke's got nowhere to go. So it spreads out over the whole continent. It's very easy here on Earth to look up at the sky and think, do you know what? That just goes on forever. That lovely blue sky, if it's a sunny day. It doesn't go on forever. Very thin atmosphere. Hence, we have to really look after that strip of gas extremely carefully. There's not much of it wrapped around planet Earth. We see other effects as well. We see glacial retreat. Now, we see that over long periods of time. We see algae blooming in the oceans, and we know that algae is growing there because our oceans are warming up, and that's an effect of climate change. And we also see large ice flows in the South Atlantic, much larger than we've witnessed in previous years, and we know that big chunks of ice are being carved off. So yeah, we see both cause and effect from space, and that's just with the human eye. I'm not talking here about all the satellites that are giving us incredible data.
Thank you very much. Thank you. And I just want to turn to the first question that was written on the wall was, why is the planet burning? Perhaps you could try and explain what is climate change?
Okay, all right. I'm probably not the expert in the room here, so I'll give you my understanding, and if I'm wrong, then please correct me. But yeah, the greenhouse effect is basically Earth gets its energy mostly from the sun. Important, by increasing it, those greenhouse gases, it has a massive warming effect on the planet. And so you can just think of greenhouse gases as a duvet over your bed, warming us all up.
Thank you very much. Now we're going to have a question from Ellie, who's here in the room.
Hi, I'm Ellie from Highland Secondary. My question is, why is space the best place to monitor climate change?
So why is space the best place to monitor climate change?
Is that for me?
Yeah.
Or someone else can take it up?
I think go for it, Tim. Go for
Okay,
it.
well, why is space the best
And
place?
I think Helco's going to come in afterwards. Yeah.
Oh, okay,
We'll get
yeah,
Helco in.
sure.
Yeah.
I mean, space is an incredible place to monitor climate change because we can step back from the planet and we can look from above and we can use the sights and sensors and equipment on all of our satellites to really be very specific about which areas of the planet we want to monitor. Are we trying to look at ocean salinity? Are we trying to look at biomass data? Are we trying to specifically look for methane blooms and outputs or nitrous oxide? And so space enables us to have that overarching view. It's just like having the finger on the pulse of the planet, and we can do that and we can monitor it from above. And it's much easier and it's instantaneous to get results and data from space, and that enables us to make informed decisions. And that's really important that we make informed decisions. We can't afford to guess and we can't afford to get it wrong.
Thank you. And Heiko, do you want to add anything to what Tim said
I
there?
can add a little bit to this. I think we are living in the golden age of space. We've never had so many space data sets as today. We can measure the chemistry of the atmosphere, we can measure the land surface, and we can measure the temperature of the planet. All of this contributes to our knowledge of climate change, and all of this has built up to the point where we are today in COP26, where we know a lot about how the climate functions and how the planet functions. That would not be the same without space data, I'm absolutely convinced.
Brilliant, thank you. And another one for the pair of you. You mentioned temperature. What's come in from quite a few different schools. How do you actually monitor temperature change in or from space?
Yeah, so shall I start on this? So land surface temperature can be monitored from space with thermal remote sensing, where we are taking the temperature at specific wavelengths of the electromagnetic spectrum, and we can turn that into direct estimates of the temperature in degrees, either Kelvin or Celsius, and also look at the sea surface temperature at the same time. So this has been absolutely critical in understanding the impact climate change has made on the oceans, because sea surface temperature is part of what drives the ocean circulation around the planet. And in the UK, we live in a place that is heavily influenced by the Gulf Stream, which is a warm ocean current that actually contributes to the relatively mild climate we have here. So all of this, I think, is really heavily influenced by the ability of measuring sea surface temperature and land surface temperature. In the UK, we have some world-leading scientists who have been involved in measuring the temperature since the beginning of the instrumentation in space.
Thank you. And perhaps you could describe, Tim, some of the different measurements we can take.
Yeah, well, just following on there, I mean, it's really interesting when I'm looking at you all sitting here. We're looking in the visible spectrum.
Yeah.
So we're seeing what people look like, but I can't see your temperature. My eyes can't give me that information. But if I can look in a slightly different part of the electromagnetic spectrum, if I can look in infrared, you're emitting temperature, and that camera can actually tell me exactly what your temperature is, because the amount of infrared energy that you're emitting is directly proportional to the temperature. So if we take our infrared cameras up into space, we can exactly see the temperature of various parts of the planet and focus on them. So that's one example of how we can actually take a measurement from space and get instant results.
Thank you. And then we had some questions in from South Lanarkshire secondary schools. I think they've set up a climate emergency newsroom. And what they want to ask, and we're going to ask all this to all of the panel, is, in your opinion, what's the most beneficial impact of space technologies that's had on our climate? So perhaps we can bring in, should we start down this end, Fred?
I'd almost prepared my answer on the basis I'd be last. So, so I work on UK peatlands. We can talk about those later, but the advantage to me is space and time. So if I had to go up and monitor peatlands, you imagine that I would have to send lots of people up on a regular basis wandering over our peatlands. But actually, because of satellites, that gets done from above. As Tim was saying, from above, I can see all of UK peatlands every day. And I can see them, I've seen them every day for the last 20 years. Yeah? So I haven't had to go back in time, and I haven't had to employ vast numbers of people. And, as Tim said, I might be ruining the answer for everybody now, I can see properties that I can't see. Right. I mean, you said thermal. The other one that's really important for us You know, I can't see your temperatures. I also can't see your water content.
Yeah.
But I can from space. And that is a whole range of properties that are really vital to my environment.
Thank you. And Donna, can I turn to you? That question
I'm
to
going
you?
to take a slightly different lilt to this. So to me, one of the most important developments that we had was, it was actually way before you guys were born. So in 1972, there was a picture taken of the Earth, which is known as the blue dot. And essentially that drove all the environmental movement because everybody suddenly realized how vulnerable we were in space. It's our own spaceship, essentially. And as Tim said, you know, when you see the Earth from space, you see, A, how beautiful it is, but A, how vulnerable it is and how we need to look after it. So to me, that's probably one of the biggest driving forces that's gone forward from that technological advancement.
Thank you. And should we go along the line, Tim? Do you want to? What's your most influential space
Yeah.
technology?
No, absolutely. I mean, seeing the view of Earth from space, that has a profound effect on you, without a doubt. But in terms of the most influential piece of technology, it's data. I can't say that enough because, you know, we need to make informed decisions and we need to make the right decisions. We haven't got the time and we haven't got the money. The money is finite. We haven't got the time and the money to get it wrong. So in order to get it right and to do it right now, we need that data so we make this really informed decisions and we do the right thing right now to get this whole thing moving.
Brilliant, thank you. And I think that turns to you, Sam. I think you were going to say something very similar.
Yeah, sure. So with my work at Earthblocks, we work to help people make use of this amazing data that we're getting from space. And so in my opinion, the best technology is actually the evolution of computing. So we use cloud computing to process through all of this data that's collected for the whole planet every single day. Without that, we would never be able to get the insights and intelligence we need to help fight climate change.
Brilliant, thank you. And Heike, your turn.
I think where space technology has made a really significant impact is on our understanding of the climate system, because we largely rely on complex computer models of how the climate works, and all these models have been developed over many decades with the help of space data. We must not forget that actually much of our understanding of the climate today comes from that combination of computer models with observations from space.
Brilliant, thank you. And so we've talked about the impacts and we've talked about the technology we have. How can we actually unite to recover cleaner and greener? Perhaps we can go to you, Donna, with that one.
Yeah, no, sure. So I think what's really important about things like COP is actually it brings together all these different nation states to talk about the problems, to talk about the challenges we face. And actually without that, we wouldn't really have this awareness. For the last 2 weeks, we've been talking about nothing else globally. So it's really important that we come together to talk about these things. And actually, once they've agreed on the targets and they've agreed on the metrics that they're going to look at, that's where space comes in. And as Tim said, you know, we can look and observe and actually tell the truth so people can't hide. We can see it all from space. We can measure the same area over and over again in all these different areas of the spectrum and actually then hold people to account. So when people are saying we're going to reforest this area or we're going to re-wet this peatland or, you know, create this urban environment that's clean and green, we can measure that and actually hold them to account. So it's really, really important that we can do this measurement from space and be very objective about it. And actually what's really important that we don't step back. We use the data that's in our hands and we can combine the different data models using things like Ordnance Survey data, using all the satellite data, and actually make sure that we can really, really action on the ground. And that's where you come in as well, because it's really important that we hold people to account, that we use the information that's given to us to our hands and actually say, yes, you are doing the right thing, or no, we don't agree with that, you're doing the wrong thing. But we are all responsible citizens to do that.
Thank you. And I wonder if we can bring Sam back in here to talk about how we're working with the United Nations.
Yeah, sure. So kind of touching on the point about uniting. So at Earthblocks, we've been collaborating with the United Nations. And so it's one thing to get all this amazing data from space. And part of my job is knowing how to handle that data and how to make it accessible and to let people do that analysis. But it's also about empowering everybody to make use of that so that all together we can help fight climate change. And so that's the focus of our work with the United Nations. They have people all over the world who understand a lot about everything that's happening in their country, and we can help them access the data that they need to understand what the best impact they can have in their country to fight climate change is.
Thank you. And going back to the Lancashire schools, their second question was, do you believe, and this is really for Tim, I think, do you believe we're getting to the point of sending too much into space?
That's a really good question. Space, is a vast place, but there are parts of our orbit that are very valuable. Low Earth orbits, geostationary orbits, and we're putting an awful lot of satellites into areas. So I think we just need to be very clever and very sensible, and we need to collaborate. We need to share information, and we need to regulate space carefully. And whatever we put into space, we need to have a plan for cleaning it up, so it either deorbits, burns up in the atmosphere, or it can take itself out into space and away from Earth. So we need to have those plans in place, and we need to regulate it so that we can use space responsibly and we can use space sustainably for generations to come into the future. What we don't want to do right now is to clutter up space so that we cannot then use it in 100 years' time. So we need to be very careful about that. And that really comes down to collaboration and regulation.
Brilliant, thank you very much. So I'm going to turn now, something that's being talked about across the road is peatlands. And I wonder if I can turn to you two. Fred, why is peatlands such a big deal? And why are we measuring them from space?
Why do we measure them from space? Well, I guess the comparison here is just to put out some facts about peatlands. I mean, peatlands are the Earth's surface's most efficient carbon store. Yeah. So you might have heard of rainforests and other environments, but there's actually more carbon stored in the peatlands of the UK than in the forests of Britain, France and Germany combined.
Wow.
So it's an incredibly efficient store. It can store in a year, or take in a year, more than 90,000 times the same as our largest carbon capture plant. So if you think of those industrial plants being developed to actually extract CO2, you might have seen pictures of them. Well, one of those is 90,000 times less powerful than our peatlands. So our peatlands are brilliant at storing carbon. They're good at taking in carbon. And so one of the things that I would say, perhaps others on the panel might slightly disagree, is the sense of, you've heard about plant a tree, yeah? Well, I would suggest that actually you might also want to preserve a peat and grow a peat as well, yeah.
Brilliant. Is that our new Space for Climate slogan?
If only, please.
Can we do that in space? Donna, do you want to add anything to that?
Yeah, no, sure. So they're obviously really, really important, but actually what's really important is that we make sure that we know where the areas to restore are. So we use satellite data to actually help us identify where the areas of peat that we need to restore in the UK are. But also we work with scientists like Fred to actually really understand how we can maximise that information to get into the hands of the land managers. So they're the people on the ground doing the work, so they use our maps in conjunction with the satellite data to really identify where are those best places to put the interventions. We can also measure what they're actually doing. So they might say they're restoring, but actually they might be causing an impact somewhere else. So we measure all that over time with the satellite data, and that's the beauty of it. It measures the same spot over and over again, so we have that long-term record. So we know how well it's being restored. And that's why we've been working very closely with Fred on this whole peatland question.
Thank you. It's really, on Adaptation Day, it's really nice to hear about things we can proactively do to restore our environment. Okay, so we are stood here in the planetarium of the Glasgow Science Centre, and a question that came up that was written on the wall was, is climate change happening to other planets? So I'm going to go back to Heiko as our scientist here.
Sure, yeah.
Can you take that question?
I can take that question. It's a very good question, actually. I think, first of all, we've got to remember that all of you and us only live on Earth. There are no people living on any other planets at this point. And it's really unique for that reason. So we have to distinguish the human-influenced part of climate change, which happened over the last 200 years or so on a very, very short time scale, geologically, from longer-term changes to climate on other planets. And planet Earth also has long-term climate cycles it's going through. Think about the last ice ages, for example. Those were influenced not by people, but those were influenced by the wobbles in the Earth's orbit. Because the Earth's orbit is not regular, as we might think it is. It sometimes is a bit further away from the sun, sometimes a bit closer to the sun. The axis of the Earth around which it rotates can tilt a little bit. And all of these wobbles are regular. That means actually we get longer-term climate fluctuations, like the ice ages, happening on the time scales of hundreds of thousands of years, or tens of thousands of years. Now, those natural cycles can also happen on other planets, but what isn't happening on other planets is the human-modified climate that we see here on Earth.
Thank you, that's really helpful. So we've heard a lot from the experts. I wonder if, Tim, you could summarise what we've heard so far. And one question that really summarises quite a few that we had on the board. Is why does going to space help us with climate change?
Yeah. Well, I think as we heard, fantastic answers from the panel this afternoon, and very informative. But space, it gives us the ability to look down on the planet, not just visually, but in so many different spectrums to get all this information. We can then take that information, we can feed it into the scientists, we can feed it into data and into modelling, and then we can make the decisions that we need to make as to where we need to invest the money to make the right decisions to make things right. And finding out, for example, about peatlands and who knew that. We've all learned something this afternoon, and I think that's really important, that we are continuing to learn and we are continuing to work out exactly what we need to do, what's going to have the best effect in the shortest amount of time. And space is an enabler for that.
Thank you. And I think we can't get away with some of the questions about being an astronaut. We haven't asked you. So there was Zara, I think it was age 4-year-old, put on there. What was your favourite thing to eat in space?
On Sunday mornings, I'd treat myself to these maple muffin pancakes. And there weren't many up there, so each crew member had one a week. By far the best thing to eat.
Brilliant. And then Ava said as well, how was it? Was it cold?
Well, on the space station, it's just like this room. It's this temperature, this pressure, about this humidity. The only difference is we've got 10 times the CO2 levels because our CO2 scrubbers are working very hard. But sure, you go outside the space station on a spacewalk, you can go from 200 degrees Celsius in the sunshine to minus 200 in the shade. So your spacesuit's having to really work hard.
Brilliant, thank you. And then it came up from Tanya on the stand and others online. Are most astronauts environmentalists?
I think, most astronauts are very conscious of the environment, and even if they weren't before, by the time you come back down, without a shadow of a doubt. But no, I think most astronauts are keen scientists. They're keen to push the boundaries of technology, of engineering, and that's exactly what we need to do when we look at the environment. Brilliant.
So there's a question from William now in the audience.
What inspired you to be an astronaut?
That's a good question, William. But for me, I started out life as a pilot, and I think what really inspired me to join the astronaut corps is I looked at that as this incredible group of individuals from all around the world who are collaborating to do something that was more special and more powerful and more constructive than any one nation could do by themselves. And I felt that was an incredibly empowering project to get involved in. And as an astronaut, on the space station, I mentioned there about pushing the boundaries of technology and engineering. We're trying to get solar panel efficiencies to the maximum we can, battery technology, water purification systems, carbon dioxide removal systems, growing food in space so that we can learn how to grow food on the planet in hostile areas like the Sahara Desert. And, all of these kind of things, I found it hugely inspiring. So for me to be able to go and join that corps of astronauts. But do you know what? I mean, I was very, very fortunate to become an astronaut, but what I'm actually talking about here is the thousands and thousands of people who are part of this incredible team, this network, who are looking at all the engineering, looking at all the science, and looking at all the technology that enables it. And there are so many careers that you can get involved in within the space sector and be part of this amazing team. So I think it's a huge part of our job as well, is getting so much satisfaction out of being part of that team.
Brilliant, thank you. We've had a brilliant team here today, and I'm not going to let them get off the hook with what inspired you as a climate scientist or a peatland specialist to do what you're doing now. What inspired you?
I love being a scientist. I don't think I could be anything else. In fact, I would struggle if I didn't get to do my job. I feel very fortunate to be a scientist and fortunate to be in a university. I do actually really love my job. I love doing experiments. I love getting answers from them. I love playing with data. And I think most recently, when this question came up, I thought, actually, I'm close to, and what I'm trying to push for is actually, I do think some of my science at some stage is beginning to make a difference. And that's fascinating to know that point, that it's not just me playing in my lab and in my field site and teaching students, which all the things I do and I enjoy, but there's also a bit where I'm beginning to actually make a bit of a difference out there. And I'm really enjoying that as well. I'm really fascinated in that bit, that actually it's not just somebody in a university ivory tower. Yeah. It is getting beyond that now. Yeah.
Brilliant. Thank you very much. Can I turn to you with the same question, Donna? What inspired you to be where you are now?
So I've got a number of loves, and space is one of those, and so is geography and maps. And to me, it's the combination of bringing all those things together to really help solve some of these climate challenges we've got. Because everything's got a location on Earth, so that's really important from a geolocation point of view, but also to combine that with the satellite data to really get those insights we need is absolutely critical to solve the problems really, really quickly. So I feel very privileged that I'm in a position to start doing that, to innovate within those areas. And collaborating across, as Tim says, is really, really fundamental. We've got to stop all this silo behaviour, or all these different countries working separately. If we can all work together, we can really solve some of these challenges really quickly. So that's why I feel privileged where we are.
Brilliant, thank you. And I'll turn this side. Sorry, I've got my back to you. Do you want to start, Sam? What inspired you to co-found your company? Or
when I was young, I really, really loved nature. I spent a lot of time there. At the same time, I really like space. Space is really cool. And I'm also a bit of a geek. I love maps. And so for me, my job combines all of those things together. But really what inspired me was learning about climate change. And it really worries me. And I can't do anything else but find some way that I can help contribute to that. And so my job, I'm really lucky. I get to combine all these things that I love, and I'm fighting climate change every single day. And so every morning I get up and I'm raring to get going, because what else is there to do?
Brilliant, thank you very much. And finally, Heike?
Yeah, I think what inspired me to become a scientist is mainly that I'm an explorer. I like to find things out. I like to discover new things. That's what got me into science. Why do I end up working with space data? Because I do think the planet is beautiful. If you look at it, you know, it's just an absolutely amazing planet. And I always love seeing new images of the planet. And I still enjoy that every single day. And in addition to what everybody else has said, of course, I'm also motivated by making a difference. Because I do think what we do is important. And we need lots more people, especially young people, to follow in our footsteps and take over when we leave.
Brilliant, thank you. And that's so. Perhaps our final question is turning back to the young people, hopefully those listening still online and those in the room. What can they really do to help climate change now and in the future? I mean, perhaps the last word to you, Tim. How can people really act?
As Ike said, it is important to make a difference and to take those small steps, because it's all about everybody taking small steps makes a massive impact globally. And it's a case of education as well, taking an interest. And I know that young people take a huge interest in their future and in the planet and in our climate. So that's a fantastic starting point. It's a case of education, and it's a case of finding out the right information and being passionate about it. I'm going to go off and do a bit more research on peatlands after today, because I think that's fascinating. And this is what it's about. It's about kind of keeping up to speed with what's going on, so that you know what you can do to make those small changes that make a big effect. And to try and have a real positive impact on where we're going in the fight against climate change.
Yeah, thank you. And I think you highlighted earlier, it's so important that space could be so many different careers to different people, and so can climate. We've got what we've called climate scientists here, but actually Space for Climate is you've got project managers, you've got media, you've got economists, you've got lawyers, you've got all sorts of different careers can all help the fight against climate change. It's about having that clear vision, and I think here in the UK we have all those skill sets. And the critical thing for me is to find something that inspires you, and to really get involved, and to think positive, because we really are. We can all make a difference. Okay, so unless there's any comments from the panel before we wrap up, I think that's the end of thank you for all the questions. For those listening in online and on the floor, thank you so much. And thank you to Tim and our expert panel for answering them. As I said at the beginning, I think those that we haven't answered that came in, we'll do written answers, and it'll be on the Space for Climate website in the next week or so. Don't forget that there are really lots of things happening here in the UK. The engineers designing and building new satellites. You've got some satellites above us that we've been signing deals here in this zone with France on microcarb. We're announcing truths. We've got biomass being built. There is a phenomenal amount of space industry, climate industry here in the UK that you guys can get involved with. When truths goes up, at the end of the 20s, that's when hopefully you guys will all be wanting jobs and careers into using the data and actually working with it. So as I said, everybody is part of the solution, and it's just for me to say thank you and goodbye from the Glasgow Centre and from here at COP26. Thank you very much.
Thank you.